Hariom. In this part, we discuss a point called pitch of the helix or pitch of the helical path. So, what is pitch of the helical path? Actually, that is the horizontal distance between two consecutive circular turns of a helix is called pitch of the helical path. What's that? Horizontal distance between two consecutive circular turns of a helix. So, as the particle moves in this fashion, that particle is experiencing a pitch. That means it is the distance travelled by the particle along the horizontal as it is moving in this helical path. Okay. Now, being that horizontal distance, this is called pitch. Being the horizontal distance, that pitch depends on the horizontal velocity v cos theta. Now, v cos theta is uniform and therefore the horizontal distance moved will be, that pitch will be equal to v cos theta into time period of the motion of the particle. Because as the particle moves along this horizontal distance, by then the particle will be completing one turn. So within that time, the particle is moving along this particular direction with a uniform velocity v cos theta. Therefore, the pitch will be equal to v cos theta into 2 pi m divided by q into b. This is the equation for pitch of the helical path. Sometimes some entrance exams and all, you will be having questions relating to pitch of the helical path, and therefore I introduce that here. Okay? Now, these are all about the motion of the particle, charged particle in a uniform magnetic field. Now let us see one problem from this part. Problem is, just for an example I am taking, that charged particles, proton and alpha particle. A proton and an alpha particle having same kinetic energy are entering into a magnetic field perpendicular to it. Then what is the ratio of the radii of the paths? This is the question. So particles are proton and alpha. Both are having same kinetic energy, entering perpendicular to the magnetic field, that is V perpendicular to V. Then what is the ratio of the radii of the circular paths? Question was very clear. What is to be found out? And ratio of the radii of their paths means they are moving in fixed circular path. So, according to the equation, R equal to m into v by q into v we have, and that is equal to p by q into v, or that is equal to root of 2 into m into kinetic energy divided by q into v. These are the equations we have for what? Radius of the circular path. Now, the one which is used in this case, as the kinetic energy is mentioned, you can take the last part into this equation, that R equal to root of 2 into m into kinetic energy by Q into V. Now you can see, as we are finding the ratio of the radii, the constant quantities will be cancelling, therefore you can remove the constant quantities from the beginning itself. Both are having same kinetic energy, entering into the same magnetic field, then 2 also there in both. Therefore, for solving the problem here, R is equal to root n divided by Q is enough. It's not equal, it is proportional. Now you can use that one as radius of the proton path proportional to root mass of proton by charge of proton, and alpha particle proportional to root mass of alpha particle by charge of alpha particle. Therefore, Rp by R alpha is equal to, you can see one by the other as Np by N alpha into Q alpha by Qp. See, Q alpha and Qp are outside the root. Now into this you can substitute the values. As they are constants, you can substitute right away. The Rp by R alpha is equal to mass of proton 1 AMU. So root of 1 AMU divided by alpha particle 4 AMU. You know that? Into charge of alpha 2 times electronic charge, charge of proton 1 times E, and finally what you are getting, Rp by R alpha equal to 1. That means radius of the proton path will be equal to radius of the path of the alpha particle. Radius of the path of the proton will be equal to radius of the path of the alpha particle. So this is how we are using those equations for solving the problems. One more thing. Here the kinetic energies are equal and particles are proton and alpha particle, and therefore you are getting Rp equal to R alpha. That doesn't mean that this is applicable to all the particles. No. That you can check by taking proton and neutron, heavy hydrogen, or neutron and an alpha particle having same kinetic energy. You can check that yourself, you can find that answers will be different. Okay? So be thorough with all the equations.